NEET 2024 Question 40. A gas stream containing 95 mole percent carbon dioxide and 5 mole percent ethanol is to be scrubbed with pure water in a counter-current isothermal absorption column to remove ethanol. So let's say this is my counter-current isothermal absorption column, and here the gas is entering here, contains 95 mole percent carbon dioxide and 5 mole percent ethanol, and pure water is coming from the top, pure, and ethanol is being absorbed in water, and of course carbon dioxide is insoluble. The desired composition of ethanol in the exit stream is 0.5 mole percent. So this is the one. That's what is going out. So it's going out with carbon dioxide, which has not been absorbed at all. Equilibrium mole fraction of ethanol in the gas phase. So in the liquid phase given. So this is my equilibrium relationship, that Y star is equal to 2x. So this is my equilibrium relationship. Assume carbon dioxide is insoluble in water and neglect evaporation of water. If the water flow rate is twice the minimum, the mole fraction of ethanol. So first we have to find out what will be the minimum water flow rate, twice the minimum. Then take the twice the minimum of that, and then we have to find out what will be the composition here. So this is where the pure water is coming in. So first we have to find out what will be the minimum value of water flow rate, and then we have to multiply it by 2 to get the actual water flow rate, and then we'll find out what is the concentration of ethanol coming out from the absorption tub. With this problem, let's quickly show here. So basically what we have, so this, I have already discussed this one. So on the solute free basis, we are showing this as capital letters. So we know these relationships, and these are all solute free basis. And if we assume dilute solution, which we can reasonably assume because this is a dilute solutions. So we can say this is a dilute solution. So we can say a capital X is almost equal to smaller. That means on the solute free basis, the mole fractions are almost the same as the actual mole fractions here. And the total flow rate is approximately equal to the inert gas flow rate. And this is applicable. This is an assumption, big assumption, only if it is a dilute solution. Okay. And same thing here. So we can show this one as is equal to 0.05, 5% ethanol. This one as 0.05, which is 0.5 mole percent ethanol here. And x0 is equal to 0. This is the pure water here. And the xn is equal to xn. Okay. With that, let's do the next calculation. We find out the minimum water flow. That part is easy. We know the ethanol balance can be done according to this relationship here. And we know when the water flow is minimum, that means L over G is minimum. For dilute solution, we can say L prime by G prime minimum. The operating line, the equilibrium line at the bottom of the tower. That is, these two are in equilibrium. Okay, that's when these two are equilibrium, that's when L over G minimum takes. So if we do that, so L over G minimum, so in this relationship here, Yn plus 1, this will be, let's call this Yn plus 1 star, because this is in equilibrium with this one, minus Y1, this one, divided by Xn minus Xg. So this is Yn plus star Y1, and in place of Xn, we replace this by the equilibrium relationship, which is this one right here. If we do the calculation, that is 1.80. So for a certain value of G, the ratio of L over G, that's the water flow rate, minimum water flow rate, is 1.80. Now, for the same value of G, we have to take twice the water flow rate. So the actual value of water flow would be two times this one. So see that. So if the actual water flow rate is 2 times of that, then we can say this is 2 times this one. So this will be 3.60. Now we use the same material balance equation here. So this is 3.60. And here we know this is the actual value 0.05, 0.005. So what will be the value of Xn? That means when I use when I use here 2 times the actual water, 2 times the L over G minimum. Okay, and these things, of course, meaning G. So, what is the value of XM? We have to find that out. So just do the calculation. The value comes out to be 0.025. All the details are shown here in this particular web. Let's look at the operating line and the equilibrium lines here on the XY diagram. So these are actually capital X and this is capital Y on the solitary basis. So this is my equilibrium line, that is y star is equal to 2x. And this is the operating line here. This is the top, which is 0.005. So this is my top here. So this is my 0 and this is 0.005. So for minimum L over G, what I have to do. So this, and we know this operating line is going to intersect right here at the bottom, right at this point. So what we do, this is actually 0.05. So from the 0.05, we draw a horizontal line where it intersects. So we come down straight right here. So that would be basically under L over G minimum. Under L over G minimum, what would be the value of X coming out, that the concentration of ethanol in the liquid stream coming out only under L over G minimum, that is given by this point here. So if I find out the slope of this line here, that gives me the L over G minimum slopes, because that's the slope of the line. So you can calculate the slope as 0.05, this one right here, minus 0.005, which one's this one right here, divided by 0.025, which is this one right here. So that's my slope. Okay. So that's the way we determine what's the slope of this line here. Okay. So that's the slope we calculate, and this is the value of the slope, and that gives me a value of 1.80, which is the L over G minimum. Now the actual value of L over G would be 2 times that, that is equal to 3.60, right? So what we have to do, so here 2 times the minimum of L would be flowing down the column. So what we have to do again on this line right here, and we draw a line with a slope of 3.60. We can do that. Once we draw the line, this will be the top of the column. If we draw a line with a 3.60 slope, wherever it intersects this line here, so that will be the point that actually the concentration of the liquid coming out. So this is value is 0.0125. It is coming when the L by G actual. That means 2 times the minimum. So this is the actual concentration when we use 2 times the L over G minimum. And you have seen that is actually the value. Details of these are of course given here in this particular website.